Hello guys, welcome back to Mezone African Motives. Still on our Power Machines N5 revisions, dealing with combustion of fuels by volume. In this case, we want to see a specific question whereby we are dealing with the combustion of fuel by volume. I've got a question which is 20 marks on everything. So let us try to see how we're supposed to attempt this typical question from November 2015 exams. We were given 20% excess air is used to completely burn a certain fuel. So we are burning a certain fuel, and 20% excess air is being used. So meaning to say we have got X representing our excess air, in this case of 20%. So we are referring to the excess air in this case, which is being required. All right, which consist of 85% carbon. So meaning to say this part, it has 85% carbon. So it is taken as 85% and 15% hydrogen. So we have got hydrogen in this case, which is consisting of 15% by mass. In this case, take note by what? By mass. The atomic mass of each of the elements is as follows. So you're given the atomic masses, of which you are supposed to know this one, but sometimes you are not given. You are supposed to know this. So you've got atomic mass for oxygen in this case, which is 16, hydrogen, which is 1, carbon, which is 12, and also we have got nitrogen, which is 14 in this case. And if you are to consider on the information that we are given, or on the percentages here, we are not given anything that is related to sulfur in this case. We do not have sulfur in this case. So meaning to say, that's why we also do not have the percentage of sulfur in this case. All right, so the question was to calculate the volumetric composition of the products. Take note, we are dealing of the products of combustion, meaning to say, after the combustion has taken place, what is going to be the product of combustion, but volumetric. Everything that we are given here, these percentages are the percentages by mass. These are by mass. And they want the volumetric composition of the products of combustion. They need of volume. So meaning to say we are supposed to convert from mass in this case to give our expressions in terms of what? In terms of the volume in this case, from mass to volume. That is the conversion that is supposed to happen. And we are talking about the product of combustion, meaning to say, from the biomass concept that we are having here, we are going to calculate the mass of the products. In this case, we are going to calculate the percentage mass of the products in this case, because we are required to work with the products. So in order for you to calculate the percentage mass of the products, remember, you're supposed to get back to the normal calculation from your theoretical formula, where you're supposed to calculate the theoretical mass of air. We calculate the products, talking of carbon dioxide. In this case, I'm just, let me list it this here. Remember, these are the inputs, carbon. So meaning to say on the products here, we shall be referring to carbon dioxide. So we shall be talking of carbon dioxide. We talk of hydrogen in this case, and oxygen, we shall have water. Also, we've got excess air, meaning to say we shall have the excess percentage oxygen in this case, meaning to say we shall have the percentage excess of the oxygen, referring to what? The oxygen, right? Then also nitrogen, which is part of air. So we've got nitrogen, remember, by mass, it carries 77% by mass. By volume, it's 79%, meaning to say we are going to have oxygen with 21%. So if we are dealing with mass, because these are the products from the mass, and as you can see, we are not given any percentage of sulfur. We do not have anything to talk about sulfur in this case. So we are not going to consider sulfur on our products. Why are we supposed to have the percentage mass of the products? Remember, there is a relationship that happens between these two. There's a relationship that we know that from our mass in this case, mass is simply equivalent to the percentage volume, or you can relate to the volume in this case times the molecular mass times the molecular mass in this case. Meaning to say, with the atomic masses that we have here, we can calculate our molecular mass. And from there, we can convert from mass to volume. If you want volume, meaning to say volume is going to be considered as the mass in this case, whereby we are going to need the percentage mass now over the molecular mass in this case. So that's why we are supposed to calculate the percentage of mass in this case, because in order for you to convert to volume, you are going to need the mass over the molecular mass. We need to say we need the mass of each product that we are given, the mass of each product, because it is the percentage of the products. That means we are going to calculate the percentage of each product. Yeah, that is where now we have to go back to that part. But from our normal conversion on our table, this is what we're supposed to have. We are supposed to have, in this case, the symbol. We can just have our symbol here. Then we have got the percentage mass, the one that we are going to calculate, which is our percentage mass. So we can just indicate this as A. All right, then we have got the molecular mass in this case. So we have got the molecular mass. In this case, we can present this as our B for the molecular mass. Then as we can see here, in order for you to obtain volume, because we need to convert from mass to volume. To obtain volume, it's the percentage mass over the molecular mass, which is the percentage mass is A, the molecular mass it's B. So in order for us to obtain the volume in this case, which is going to be A over B, where is the A over B coming from? The A over B is coming from the mass over the molecular mass concept. So here we are simply presenting the mass over the molecular mass in this case. That is what is happening. So since we have the volume in this case, we are going to add everything. Then we calculate the percentage or by volume. So we are going to calculate the percentage by volume. Since you have calculated the volume, you now have the volume of everything. So you can calculate the percentage by volume. So on this table that we're going to have, we are limited because we do not have the percentage mass of the products. This percentage mass that we are talking about here is of the products, as I explained, of the products. We are dealing with the products in this case. So we are supposed to get that corresponding percentage from the products of combustion, but by mass, because it's the percentage by mass. We are talking about of the percentage by mass. So we are supposed to go back to the percentage by mass. All right, so I'm going to have the table. Then we insert, we take our information from by mass, then we come back and substitute on this table that we are seeing here. So that's this how our table actually is going to look like I was explaining from this part, that we're gonna need the volume. So here we're going to need the symbol, the percentage mass from the products, the molecular mass, which is gonna take from our atomic masses here, then the volume, which is A over B, that is the mass over the molecular mass concept, the percentage. Then we can calculate the percentage by volume. That is the whole situation. So as we need the mass of each of the products, therefore let us calculate them, which is from carbon dioxide, excess of air, and so forth. So these ones we can take them from our formula. Yes, we can just calculate them direct, because we can obtain the mass of from the formula, theoretical mass. Remember, I explained and also presented this formula that we can use to calculate the theoretical mass of air in this case, whereby we're dealing with theoretical mass of air. So we can need this because we're going to need the actual mass of air in order for us to have nitrogen. So there's a lot. And also on our formula, it has a lot of things that we are supposed to consider. So remember, it's 100 over 23 times the mass of oxygen, which is 8 over 3 C plus 8 H2 plus the sulfur minus the oxygen in this case like this, whereby this whole presentation is representing the mass of oxygen in this case, the mass of oxygen. So we are going to have the mass of oxygen to burn carbon, the mass of oxygen to burn hydrogen, the mass of oxygen to burn sulfur. That is the concept that we are going to have. So here we are simply substituting the percentages that we are given in order for us to have the theoretical mass at the end. So we are going to have 100 over 23 into 8 over 3, which is same as 2,667 kgs, all right? So times the percentage now of carbon. If we take the carbon, it's 0,85 from 85%. So we are going to use 0,85 in this case, all right? So that's times 0,85 plus the mass of oxygen in hydrogen, which is in hydrogen. Well, how many are we having the percentage there? It's 15%. So 15%, that is going to be 0,15. And for sulfur, as we can see, we are not given in this case the percentage for sulfur. So we take it at 0%, taken at 1 kg of the fuel. So it's going to be 1 times 0 in this case, minus the oxygen. Oxygen in this case, the percentage, we are also not given the percentage for that oxygen. So we are going to take it again at 0%. So that's it. We are going to obtain the theoretical mass of air in this case. So that's 100 over 23 times the mass of oxygen, which is simplify this whole part here. This part gives us the mass of oxygen, which was going to be something like 3.4666 and so on and so on. So multiply that value by 100 over 23, we obtain the theoretical mass of air, which was going to be 15,072. So this is the theoretical mass of air per kg fuel in this case. So it will be taken per kg of the fuel in this case. That means per each 1 kg, as we use our first principles concept, remember that. So like I said, mass of oxygen. So here we've got the mass of oxygen in this case, all right? So that was the concept. Now we can calculate the actual mass of air so that we can have our product, which is nitrogen, because in order for us to have nitrogen, we are supposed to use the actual mass of air from the excess air, that percentage that we have of oxygen, the excess percentage there, what was our percentage? 20% excess air in this case. So meaning to say our X is at 20%. So meaning to say we can calculate the actual mass of air in this case. So the actual mass of air is going to be taken from the theoretical mass of air times 100 plus the increase, which is the excess air over 100%. So that's it. The mass of air, theoretical mass of air is 15.072 times 100 plus 20. That is 120 over 100. So this was going to give us the actual mass of air, which is going to be 18,086 kgs taken per kg fuel in this case that is given. So we are talking about the actual mass of air in this case. Why calculating the actual mass of air? Because we need to have the product here, which is nitrogen. It's part of our product in this case. So now we are to calculate our products, as we say, from our products. So from the actual mass of air, we are going to obtain nitrogen there as by mass, because this is taken by mass, and by mass nitrogen consists of, the air consists of 77% of nitrogen. So meaning to say we are going to have 77% of actual mass of air, in this case. So that is the actual mass of air, 77% of it, 18,086. We are going to obtain the mass that is corresponding to the our product, which is nitrogen, as 13,926. So nitrogen is part of air, so that's why we have to consider it on our product. It's part of air, all right? Then carbon dioxide also, and these others, we are going back to our products. Remember, we said we are going to need carbon dioxide. So the carbon dioxide It's a product from the input of carbon. In the input of carbon, we have got 2,667 kgs of oxygen. This is the mass of oxygen. So meaning to say together as a product per kg, remember this is taken per kg in this case, per kg, which is per 1 kg. So we are going to add the 1 kg of carbon in this case. So at 2,667, we add 1, we are going to have 3,667 kgs of carbon dioxide as a product. So we need the mass of the product, which is 3,667. So that is what we are going to have here for carbon dioxide. So for carbon dioxide, said we are going to have 3,667 kgs of carbon dioxide times the percentage now of carbon. Remember, our carbon is taken at a certain percentage that was at 0,85 here, at 0,85, hydrogen at 15%. So we've got 0,85. So we are going to multiply by 0,85, which is the percentage of carbon in this case that it was going to give us the mass of carbon dioxide, which is as an output 3,117 kgs. Then we move on to the water. In this case, we saw that water is a product again, and water, how many kgs of oxygen do we need in order for us to burn hydrogen? We need 8 kgs of oxygen in order to burn hydrogen. So we are going to have 8 kgs plus 1 kg of what? Of hydrogen, because it's taken per 1 kg. So at the end, we are going to have 9 kgs of water in this case. So 9 kgs times the percentage of oxygen. So that was the concept that we are going to obtain in this case, times the percentage of hydrogen in this case. So we are going to obtain, remember it's 9 kgs and the percentage was 15%. So 15% is 0,15. So that is it. We obtain 1,35 kgs in this case. Remember, we do not have sulfur, so we are not going to have sulfur dioxide as a product. So sulfur dioxide is not there, but excess air is going to be included in this case. So also we are going to be talking about the excess oxygen from that excess air. So the excess oxygen is simply X%, which is the excess, times the mass of oxygen. We are going to consider the mass of oxygen in this case. And our excess air is at 20%. Remember, the excess air was at 20%. So it is going to be 20%, which is 20 over 100 times the mass of oxygen. The mass of oxygen is the one that we also have on our theoretical formula here. Remember, we're saying it's 100 over 23 times the mass of oxygen. This whole part representing the mass of oxygen, which is the one that we got here, the mass of oxygen, 3,467. So it's going to be 3,467 to 3 decimal places in this case. That's the mass of what? The mass of oxygen. So that is how we are going to take our values, which is 3,467 as we calculated before. So that was going to give us the excess oxygen of 0,693 kilograms in this case. All right, so these are our products. And as we to check on our table, we do not need to know only the products, but we need to know the percentage mass. We need the percentage mass of the products. So in order for us to obtain the percentage mass of each and every product that we are given, because these are our products here, so we are supposed to obtain the product of each, I mean the percentage for each. So we are going to need the total mass in this case. That means the total mass is going to be equal to what we add all the masses that we are given for nitrogen, for carbon dioxide, for water, and for excess oxygen in this case. So that was going to give us something like 19,086 kilograms. So we now have the total mass. So in if we have the total mass, therefore we can calculate the percentages, the ones that, because that is the one that we need on that table. The table is representing the percentage of each. So meaning to say we are going to calculate the percentage corresponding in this case to nitrogen, in this case, the percentage corresponding to nitrogen is going to be the mass of nitrogen that we are having over the total mass. So that's 13,926 over the total mass of 19,086 times 100%. So this gives us the percentage mass. Remember, we need the percentage mass, the percentage mass. So that was going to be 72,964%. The same thing, or the same concept for carbon dioxide, we are going to have the same thing. Carbon dioxide, the mass of carbon dioxide over the total times 100%. So this was going to give us 16, if we simplify, remember I said the mass of carbon dioxide over the total mass times 100%, this was going to be 16,331%. You do the same thing for water. The percentage for water in this case is the mass of water over the total times 100%. That was going to be 7,73%. You do the same thing for excess oxygen in this case. So for excess oxygen, it's the mass of excess oxygen 0,693 over the total mass times 100%, which was going to be 3,631%. So this was going to give us the total percentage of 100%. So this one was 99.9. It's because of the rounding off part, maybe. So you just have to be careful on your rounding off part. But if you round off properly to the nearest whole number, that will be 100%. So as long it's 99.999 and something, that answer is fine like that, because you were rounding off this value. So you can't be specific to say, in order for you to have 100%, this one I'm going to round to 1 decimal place, this one around to 3 decimal place, this one around to, it can't be like that. Just maintain the same rounding off. If you are using 3 decimal places, maintain that throughout. Your answer is going to be considered correct. So with these products, now we remember here, what are we calculating here? Let me indicate properly. We are calculating the percentages by mass. Or from where? From the products. These are the products that we wanted, because on our table we said we need the percentage here, the percentage of mass, the percentage by mass of the products. So now we are going to indicate each and every product in this case on our table, so that we are going to have the corresponding percentage by volume, or the volume on itself. All right, so you're gonna start. You can even start with carbon dioxide. Remember, we had carbon dioxide. The percentage for carbon dioxide in this case by mass, it's 16,331. This is the percentage of what? Carbon dioxide. That is the percentage that we need here. So the percentage of carbon dioxide was 16,331% by mass. Then the molecular mass, we go back to the atomic mass concept. Remember, from our atomic mass, we have got 1 carbon. So it's going to be 1 times the number of carbon, the atomic mass, which is 12, plus the oxygen, there are 2 of them, times the atomic mass of oxygen, which is 16. So this gives us the molecular mass of carbon dioxide, which is 44. Then the volume, we said it's mass over the molecular mass, percentage mass over the molecular mass, that's A over B. So percentage mass, molecular mass, so you're simply dividing A over B, that's 16,331, that's our A, over our B, which is 44. That is what you're simply doing. So you're going to obtain 0,371 to 3 decimal places. Then for percentage volume, we are going to need the total volume. Then we can calculate the percentage volume, all right? Then we move on to water. We can consider water as a product. Remember, by percentage, by mass, our percentage by mass for water in this case was 7,073. So that is the percentage that you're going to take for water in this case, all right? So that means water percentage is 7,703%. Then we calculate the molecular mass according to the atomic mass. Hydrogen, we have got 2 hydrogens in this case, times 1 according to atomic mass, plus oxygen, it's 1 oxygen times 16 for oxygen, which is going to be 18. So we're going to obtain 18. The same thing, volume, mass over molecular mass, A over B. So A here is 7,073 over B, which is 18. So we are going to obtain, in this case, that was going to be 0,393. Okay, we do the same thing. We also had excess of oxygen and nitrogen. All right, so let us just indicate excess oxygen. All right, the percentage as we calculated by mass for oxygen, this was our percentage for oxygen, which is 3.631. All right, so you're gonna have 3.631 there. All right, 3,631%. Then the molecular mass from our oxygen, we have got 2 oxygens times the oxygen is represented by 16. According to atomic mass, oxygen it's 16. So it's going to be 2 times 16, which is 32. The same thing, A over B, that's A over B. We were going to obtain 0,113. All right, we do the same thing. We are left with nitrogen. In this case, nitrogen by percentage of mass, it was taking 72%, 72.964%. This is the percentage of nitrogen by mass on our products in this case. So we're gonna need the percentage here, which is 72.964%. All right, then we can fill up our table, calculate the molecular mass. Nitrogen, there are 2 of them, times the atomic mass of nitrogen, which is 14. Okay, if you check, all right, so given nitrogen is 14. So it's gonna be 2 times 14, all right, which is 28. So that is it. A over B to find our volume, that's A over B, A percentage mass over molecular mass. So you divide this value to 28, you are going to obtain 2,606. So thus we now have the volume. We can find the total volume from this value. As we calculated our percentages here, we had a total percentage of 100%. We are going to do the same thing for the volume. You are going to need the total volume so that we can calculate the percentage of each volume, because we need the percentage by volume. So what is going to be the total volume of everything? If we add this, we are going to obtain 3,483. That is our volume in this case. So in order for us to obtain the volume that corresponds to carbon dioxide, we are going to need the volume of carbon dioxide, 0,371 over the total volume, 3,483 times 100%. That's it. We are now calculating what? The percentage volume. So that was the concept, which is going to be 10,649%. You do the same thing for water, the volume of water over the total volume times 100%. That was going to give us 11,283%. The same for excess air, excess oxygen, the volume of oxygen over the total volume times 100%. This was going to be 3,244%. Then for nitrogen, the amount of nitrogen, which is the volume of nitrogen over the total volume times 100%, that was going to give us 74,821%. Then we combine everything. So it was going to, according to my values, was going to give us 99,999 and so on. So that's a total of 100% in this case, all right? So that is how you calculate these values. Like I said, you can't be accurate to say this value, I'm gonna round it to 2 decimal places. Maintain your rounding off of values. If you are using 3 decimal places, maintain that throughout. The answers, they are very, very correct. So let us try to revise as much questions as we can, preparing for our tests and exams, which are ahead of time. Let us try by all means to work with more question papers. This can help you as you are revising for the examinations that are ahead of time. But for now, that's it, guys, from Mason African Motives. Till we meet again.